Welcome, friends. I welcome you to today's session. In this session, I'll be taking you through Senior 4 Final UNEB Preparation. This is our online facilitation that we are having today. And as we're saying, we need to learn, revise, and pass with confidence. It's Isaac Nyirimbibi today who will be taking us through this online facilitation. I want to request you to get your notebook, get your pen. Today we shall be looking at our final preparation to UNEB. UNEB has a few days to go, and we do our chemistry paper 1 and the chemistry paper 2. In this session, I'll be taking you through paper 1, and then in our next session, I'll be taking you through the final preparation for paper 2. Please don't forget to keep on pausing. And also, for those who have not subscribed, please click on that subscription button, click on the notification button, and don't forget to share with your friends so that they don't miss out this final UNEB preparation on chemistry paper 1. Let's dive into this simple introduction. Now, in this introduction, I know we already know that now in chemistry you have 2 papers, and the code is 545, where we have the 2 papers, the paper 1 and paper 2. Paper 1, which is theory, and it's a one we are going to finalize in this session. It's a one we're going to look at those different mistakes that learners have been making. That's those errors that learners made in mocks. And we don't want them to do the same errors in the final UNEB paper. And therefore, this session is very critical, a masterpiece for you to go through until the end. Please make sure you don't move away until the end, because we shall be doing a number of items on different, from item 1 up to item 6 in a standard paper. As we said, in paper 1, they are scenario-based items and it is 2 hours. So we're going to see how do we maximize the scores and we get all our A's. We get our A's in this UNEB, just utilizing the 2 hours and maximizing the scores. In our next session, that's when we shall be looking at the practical part. Just wait for us in the next session. But in this session, I will be summarizing paper 1, hinting out those common errors, the errors made by learners during the mock, but also even other errors and some new changes that have come in how to respond to different items. As we say that our assessments still target on KUSIVA, on the knowledge, understanding, skills, and values. Not only just knowledge, but we want to see, can you apply the skills that you have attained during the 4 years? This is end of cycle assessment that we are preparing for. So we want to see a learner showing the knowledge, showing the understanding, showing the skills attained in this course of 4 years. And therefore, we're saying that in this final preparation, we need to sharpen the exam technique. So today we shall be looking at the exam technique. Which techniques can we employ in approaching different items and avoiding the common errors? Let's dive into item number 1. We said item number 1 is the one which lies in the element of construct, which looks at a learner appreciating chemistry in our daily life. For that one, I believe we saw that in our previous facilitation that we had before mocks. And in this final preparation, we have not put all the other details. We are looking at our final touch. We are looking at those common errors, those errors made in mocks. What are we going to do to avoid those errors again in UNEB? Let's look at our accessible areas. So we know very well that we have the 4 accessible areas, the 4 topics from which item number 1 can come from. Number 1 is medicines. Now, in medicines, we say that under medicines can be categorized into 2 categories according to the source. Now, we say that according to the source, medicines can be traditional, but also they can be categorized as modern medicines. We also said that we can categorize medicines according to their functions. And I believe most of the items, if we have gone through different mock bodies, we have been able to see that a number of items have been set on medicines, and they are looking at according to how they function. For example, let's look at, there are those medicines which we call or we categorize as analgesics. Now, the ones we categorize as analgesics are those ones which work on the pain. In simple terms, they are painkillers. So, which means if we have a scenario and we have maybe someone who has been feeling some headache, feeling some stomach ache, now, all those ones, the tablets this person needs, the medicine this person needs is what we call analgesic medicine. That's where we find the Panadol. That's where we find the bitter leaf. Now, bitter leaf is under tradition medicine, while the Panadol, which is another painkiller, is under modern. So you can see analgesic can be under traditional, analgesic can also be modern. Hope that one is clear. Today we shall be looking at even an example which is worked out, and we see how best we can apply whatever we are talking about. Now, we also have another category of medicine which works on the infection, specifically looking at bacterial infection, and we call those ones antibiotics. Antibiotics. So we have seen learners or people in the community, maybe you have gotten a cut, a wound, and you fail to go to the hospital for medication or apply any medicine, then some pathogens start entering and find the leg is swelling, all that. So those pathogens, those bacterial infections, they can be worked upon by a category of medicines called antibiotics. We also have another category, the one we call psychotherapeutics. Now, for psychotherapeutics, these ones are mainly looking at the brain function and on the mind, actually. Mind and the behaviors. Those are the psychotherapeutic medicines. Then, there's another kind of medicine that we can talk about, antacids. Under antacids, these ones are like alkalis. This topic is covered in a senior 2 about acids and alkalis, and that's where we find the antacids. So we can, and these ones, how do they function? They function by neutralizing the acid. So they work by neutralizing the acid. So as we get to know the different categories of medicines, we need to know how they function. If it is analgesic, how do analgesic medicines function? By inhibiting the sensation of pain to the brain. Are you seeing that? Antibiotics, by inhibiting the growth and multiplication of bacteria. Are you seeing that? So what are we saying? Get to know the categories, but also don't end there. Continue to see how do these function. There is another category which I don't want us to leave out, the antiseptics. Now, for antiseptics, these ones, they work also by inhibiting the multiplication of microorganisms, or even the pathogens, but majorly on the wounds, on the active parts. Now, for example, active parts, when you talk about the active parts or active tissues, let me use that one, I believe it's better. Active tissues, for example, the wound. You have cut yourself, you're bleeding. Which medicine do you need? You need a category of medicine called antiseptics. So I believe most of us are used to these three categories: the analgesic medicine, antibiotic medicine, psychotherapeutic. But now there's this one, the antacids. I believe that one we have gotten it today. And also we have the antiseptic. And this one is saying, for it normally works from outside, working on these microorganisms or the pathogens which are on the active tissues, like on the wounds, and we apply it outside. While when you look at antibiotic, for it we take it orally inside or through injections in that manner. So this antibiotic can still work on the same thing of antiseptic, but the difference is that this one is applied out, this one is inside, and so we can see that all these are the different categories that we can have under medicine. And as I said, don't end at knowing the categories. Also continue to understand how they function. Okay, hope that one is clear. Please, if you have any inquiry, make sure you put that in the comment section, and I'll be able to respond to you. I'll be able to respond in time. So let's go to food additives. Now, in food additives, even food additives can be categorized in two ways. Number one, according to the source, where we have the synthetic, and then we have those ones which are natural food additives and synthetic food additives. But also, we can categorize the food additives according to their function. I know our teachers have helped us to understand these different categories. For example, according to how they function, we have those ones which help in preservation, and therefore we call them preservatives. We have those ones which help us in making our soup thick. I believe each one of you like soup which is thick, not dilute. Yeah. So we need a category of food additives called thickeners. Okay. Forgive the handwriting, but I believe it is somehow clear. Then we have those ones which help in adding maybe the sweetness, the taste. So those ones you can say they are called sweeteners. Okay. Which other category? We have those ones which are, we have others which are adding on color. We have those which we call the colorings. Then those which are adding flavor, we call them the flavorings, and so on. We have antioxidants and very many others. Of course, I may not list all of them, so I'm going to say etc. So we are saying that even here, when you come on the function and we talk about preservatives, these preservative, we can have a preservative which is synthetic. We can also have a preservative which is natural. So we can categorize these food additives both according to the source and also according to the function. So these are the two ways that we can categorize the food additives. Then we have detergents. Now, detergents can be categorized according, we have only two kinds of detergents. Number one, we have the soapy detergents, and we also have the soapless detergents. So those are the major two categories of detergents that we have: the soapy detergent and also the soapless detergents. And we don't need to end at this. We need to also understand how each one of these function. Now, for them, we don't look at how they function. How they function is the cleansing action. So here we look at the cleansing action, and we say that the cleansing action of soapy and soapless are the same. So they have the same cleansing action. What are some of examples of soapy detergents? I believe now you know the different examples. We have the bar soap, the Star white bar soap. Then soapless, that's why we have these other detergents like the Omo, we have the Nomi, we have the Sunlight, and very many others. So we can also categorize detergents in those two ways, either soapy detergent or soapless detergent. Then finally we have the last topic, which is nuclear processes. And we say that these nuclear processes can be categorized into two. We have the nuclear fusion, and we also have nuclear fission. Though we can have also radioactive decay. But the major categories of these processes, we have two major nuclear processes, and we said the first one is the nuclear fusion. Then the second is the nuclear fission. So we have the two major categories of nuclear processes. Now, how do we approach items under this number one? How do we approach? They have set an item under number one, a standard paper of chemistry, and now we want to see how do we approach. So number one, we need to read the scenario, and then from the scenario we identify the product which is being talked about in the scenario. Now, after identifying the product, we categorize it. Which category do we talk about? Now, the categories are these ones. If it is under medicines, it is maybe an analgesic medicine, it is maybe an antibiotic, it is psychotherapeutic, it is maybe antacid, antiseptic. So the categories are here, but you need to categorize according to the scenario. So you read the scenario very well, and then you identify the product. Finally, you'll be able to categorize that product. Then number two, we describe how it works. Now, how it works or how it functions. So if it is under medicine, food additives, nuclear processes, we explain how they function. Then in detergents, we said we explain the cleansing action. We explain the cleansing action of maybe soapy detergent or soapless detergent, but as we said, their cleansing actions remain the same. That is number two. Then number three, we state the danger and mitigation. We shouldn't end at stating the danger. Give the danger, explain your danger, and then you mitigate it. So we shall be able to see an example of such, where you are identifying the danger, explaining the danger, and then mitigating the danger. Then finally, we can look at evaluation. In evaluation is where we need a similarity. Only one similarity and a difference. Similarity of what? For example, if they are talking about an analgesic medicine, it will depend on the scenario. So when you read the scenario very well, you'll be able to understand whether they are talking about analgesic. Now, in evaluation, we can talk about the difference between maybe the traditional analgesic and modern analgesic medicine. So if it is detergents, then we need to evaluate between a soapy detergent and suppress detergent, giving one similarity and giving one difference. So let's dive into an item and we see how we can attempt an item under number 1, and we apply whatever we have learned from here. So let's go through this item number 1. This item number 1 is saying that during a campaigning, we have this. Are we able to see this? Yes. During a campaigning rally organized in newly constructed playground, one of the supporters got a small cut on his foot by a rusty metallic bar. Yeah, this is one of the items which was set in the recent mock assessment. Hope some of you have already seen this item, and we want to see how we can use whatever we have learned to attempt this item. So they're saying that one of the supporters got a small cut on his foot by a rusty metallic bar as he was dancing and morale boosting. Towards the end of the rally, he realized that the foot had got swollen. He thought it was fatigue, but on visiting a nearby hospital, the diagnosis revealed an infection. In order to kill the pathogens, metronidazole tablets were prescribed to him. When he reached home, he abandoned the physician's prescription, arguing that the medicine has many side effects, and instead he took a green extract. From plants around. After 3 days, he had not improved and could not find a solution. He has met you and has asked you for advice. So why did he fear? They prescribed for him, but when he reached home, look at this, he abandoned the physician's prescription, arguing that the medicine has many side effects. But now, let's read very well, because the task is saying that as a chemistry learner, explain to the supporter the category of the product that was prescribed at the hospital and how it works. I think they want us how it works, and we categorize. Hope you recall what we had here. In this case, you call number 1, identify the product and categorize it. Describe how it works. Now, we want to find out which kind, because we see it is under medicine at least. Is it traditional or modern? We can also identify that. Then after that, under function, according to the function, which category of medicine is that they are talking about? Let's again read through. So they are saying that he thought it was fatigue visiting nearby hospital. Since he went to the hospital, in hospital, do they sell a lot of traditional? No. Because you see, the diagnosis revealed an infection. Now here there is an infection. It gives us an idea. In order to kill the pathogen, now you see, pathogens, tablets were these tablets. So which means this is a modern medicine. But what is it working on? On an infection. To kill what? Pathogens. Which kind of medicine does that? The antibiotics. Are you saying that? So in that case, you'll be able to know that it is modern antibiotics medicine. Are you saying that? Here they want the category just. So the category of medicine this person used is modern. Because for him, when he went home, he used plant extracts, meaning that was traditional medicine he used. But they had prescribed for him, and here they are saying the category of product that was prescribed at the hospital. So that is a modern. So they wanted us also to mention modern. According to the function, it is antibiotic, which helps in killing the multiplication of the pathogens. So, which means that one becomes antibiotic, and then we can explain how it works. Then part B, help the supporter to understand any one side effect associated with the use of the product above and how this side effect can be mitigated. Then finally, how would you evaluate, let's remove D, the different categories of products that can be used on infection? The different categories, I think here it is very clear. Different categories. There's the one he used at home and the one they prescribed for him at the hospital. So we can be able to see that part A, someone could just say that the prescribed product, please, these are common errors that learners make. For them, they just come and say, modern medicine. No. In the question, they said, category of product that was prescribed. So I come and say, the prescribed product is modern medicine, category 1, and I give you scores. How it works? It works by inhibiting the growth and multiplication of bacterial pathogens in the body, allowing the body's immune system to clear the infection. Very good. And you get all your scores. So the function will give you all the 4 scores, and the category will give you all the 2 scores. So that's why I said we need to maximize all the scores. Let's go to part B, side effect of what? Of the antibiotic. Now they're saying that the product may cause nausea, that is the danger, dizziness, fatigue, or skin irritation, thus leading to body discomfort, that is the effect. This can be mitigated through reduced, can be mitigated, let's remove this, by drinking plenty of water, resting adequately, and strictly following the doctor's dosage. That is the mitigation. And you get all your 6 scores. That's what I'm saying. Can we see how we can maximize all the scores? So here, you'll be able to get all the scores. But when you get all the 6, you have given this danger, you have explained it very well, and you mitigate it. Then let's look at part C, evaluation. In evaluation, we said look at the similarity and the difference. So I say that both categories, which categories are we talking about? We have the modern and the traditional medicine. And these are all the antibiotics. So both contain useful chemicals. They all have the useful chemicals, that is the similarity. But modern antibiotics are more reliable and effective for serious bacterial infection compared to tradition. So that is the difference that is being mentioned. So here we need only one similarity and then one difference. So you give all the 2, 1 similarity, 1 difference. Each of these gives you the 3 scores, and even this one 3 scores, giving us a maximum of 18 scores. So we can see that if we maximize all the scores on this number, we are able to get all the 18 scores. Yeah, so let's see now our item number 2 for section A. Okay, now on item number 2, that is our next element of construct. And in this element of construct is where we say that the learner appreciates the different substances and the interaction of these substances. So we are just summarizing it. In our first facilitation, I believe we are able to see all those in details. But today we want to focus on our UNEB. What is it that we need? Where in this item number 2, which topics can we get? And one thing I want to remind us, when we come to item number 2, when we are in item number 2, we have to make sure that we look at these things. If you look at, maybe let's look at the first topic, elements, compound, and mixtures. If you recall very well, all this topic is covered in Senior 1. Now, when you're reading this topic, don't forget that in this item number 2, we need to know the different categories. If it is elements, can we categorize these elements? Are you seeing that? How do we categorize these elements? Elements can be categorized maybe as metals. Are you seeing that? Metalloids, and then non-metals. I'm just giving you a hint of what you're supposed to do when you're reading these topics. If it is elements, understand the different categories of elements. And then, don't end there. Understand the properties of these elements. Don't end there also. Understand the effects or impacts of these elements and how you can mitigate their impact. Are we there? Then, number 2, it is compounds. Don't end at knowing compounds, but understand the different categories of compounds. Under compounds, we have those we call ionic compounds. We have those we call covalent compounds. And then, I believe those are the ones. Covalent compounds and ionic compounds. Understand the characteristics, the properties of ionic compounds, or properties of covalent compounds. Under mixtures, if you recall very well, we had kind of mixtures where we have the heterogeneous and homogeneous. I'm not going to be writing everything, but I'm just hinting on such. So on mixtures, don't read mixtures and you stop there. Understand the categories of mixtures. We have heterogeneous and homogeneous. Then, under mixtures also we have the liquids. The categories of liquids, where we looked at these categories as the miscible liquids and immiscible liquids. Don't forget that also these ones exist. So I believe that's all I could talk about on that topic. Don't end at just knowing elements, compounds, and mixtures. Understand how to categorize. Metals. Where do we find metals in the periodic table? From group 1 to group 3. Group 4 elements, most of them are metalloids. From group 5 up to group 7, those are non-metals. Up to group 8 are non-metals. So all those categories are very important for us to know, and not ending there, understanding the properties that make them good for purpose. Then periodic table, I believe we have already hinted on the periodic table already, because under periodic table, we also find there these elements and we can categorize those elements. Another is trends in the periodic table. I've discussed a number of sessions. In the different sessions, we have discussed a number of items under trends in periodic table. And in trends in periodic table, we are looking at different physical properties. For example, you can talk about hardness. You can talk about density. You can talk about boiling points and melting points. Now, when we are talking about these physical properties, the hardness, the density, the boiling points and melting points, when we are talking about them, you recall we are looking at specifically at O level, we are looking at period 3. We are also looking at group 1 elements. So let us understand the trend in the hardness of period 3 elements, of group 1 elements. Also understand the properties of those elements, side effects of those elements, and how you can mitigate. Let me hope that is clear. Please don't leave any stone unturned. Turn all of them. Tackle every topic very well. I'm spending time here because surely we need it. we need to be reminded some of these things. Then, under structure and bonding, did you know that there is a question they can send and they ask you to categorize the kind of bond present? We have the different types of bonding, where we have like metallic bonding, we have ionic bonding, we have covalent bonding. For now, I believe those are the ones that we know at O level. The metallic bonding, common in metals, ionic bonding, between sharing electrons between a metal and a non-metal. Then covalent bonding, which is, ionic bonding involves transfer. That is a key word. Transfer of electrons from a metal to a non-metal. Then covalent bonding is where we are looking at sharing of electrons between non-metals. That is clear now. Now, let's look at another topic. Please don't forget that anything which is undergoing metallic bonding, that is a metal. One undergoing ionic bonding, those are ionic compounds. The ones which are undergoing covalent bonding, that is covalent compound. So you can see that we are still covering the other part of elements, compounds, and mixtures. Of course, in senior 1, you didn't look at ionic compounds, covalent compounds, but by the time you finish senior 3, under structure and bonding, you're able to know all of that. Then formulas, stoichiometry, and mole concept. Here, we need to be knowing different calculations. Number 1, about moles, maybe changing moles to mass. Then we molar gas volume. Don't forget applying the stoichiometry. Stoichiometry, we are just looking at how we can use balanced equations to determine the amounts of products produced or the amounts of reactants being utilized. So that is where, that is actually, in simple terms, that is the summary of mole concept. Understanding the formulas of different compounds, writing balanced equations, determining moles, mass, determining the formula. Don't forget the formulas. In the formulas, that is where we have the empirical formula, and then we have the molecular formula. Please don't forget these two: empirical formula, molecular formula, applying stoichiometry, using molar gas volume, and then moles, mass. That's where we have also the particles, like that. So go to that topic, find out what is still disturbing you, and you go through that topic very well. There's a full session I've shared about mole concept, having different numbers discussed. So please don't forget to go to the channel, find that mole concept. I called it cracking mole concept. You'll find it there. Now, we also have another topic, using materials. Now, using materials, it is covered in senior 1, and under using materials is where we categorize these materials as natural. They are either natural materials or synthetic materials. This synthetic also can be known as artificial materials. Natural and the synthetic, these ones which are made by man. Then carbon in life. Carbon in life, it has a number of categories of substances that we can categorize in different ways. That's where we have the hydrocarbons and the hydrocarbons. We have, and in this we also have different homologous series. Homologous series. Under homologous series, the groups in homologous series, we have these hydrocarbons, the alkanes. We have alkanes. We have the alkenes. We have alcohols. We have carboxylic acids. And what? Okay. Now, we have alkenes, alcohols, carboxylic acid. Now, when we need to go back and you see, how can you be able to know this is an alkane? How can you be able to know this is an alkene? How do you know this is an alcohol? This is, so we get to know all those different categories. So polymers, we also looked at them in senior 3 and also in senior 1. Then there's this topic, reactivity series. When you're looking at reactivity series, looking at which one is more reactive than the other, because reactivity series, we said, is a list of metals in the order of their reactivity. In the order of their reactivity. And don't forget, we also have the alloys. Alloys, these are substances which are formed when a metal is mixed with another metal, or combining a metal with other elements. Why do we do that? To improve on their properties, like hardness, strength, all of that. And under alloys, we have examples of alloys. We have like steel, we have brass, we have bronze, and brass, steel, and others, which I believe you have looked at. So you need to go back and look at those alloys. There is a question that you are going to look at today, which involves all that. Then the other ones, please go back to our first facilitation, go back to the different sessions I've shared. All these topics have been covered. There's no topic that is here that I have not covered on the platform. So check in the platform and go through them. The one which you had not covered is on alloys, and today I've come with an example on alloys and also on the mold concept. That's the one we shall be looking at. Then we have polymers and plastics, and those ones. Please understand the properties of plastics. Understand different properties that make them suitable, the side effects, and how you can mitigate. Then we have air. Now, under air, when different substances burn in air, they also form oxides. So don't forget about oxides. Oxides can be covered under air, but also they can be covered under trends. Under trends in the periodic table. In trends in the periodic table. Looking at the trend on the reaction of period 3 elements with air, or group 1 elements with air. So we need to look at this very well. And under air, we also have rusting. So we can categorize, like now, rust, that is hydrated iron 3 oxide. Hydrated. Now, if they ask the category of this, can you be able to give it? Someone can categorize this as ionic compound. Another person can categorize it as in terms of oxide. Which kind of oxide is iron oxide? So someone can also say it is a basic oxide. These two people will be right, so long as they know the reason behind that. I'm just asking you, have you gone through oxides? Have you gone through topic called air and have seen combustion? Because when combustion is taking place, we form oxides. And these oxides can be categorized as basic oxides. Let me just put for you. We have acidic oxides. We have amphoteric oxides. We also have the last one, which is neutral oxides. Yeah, this young boy is there ticking that, yes, basic, number 1. We have acidic, amphoteric, and neutral. Good. He's very serious. So you can see that we can categorize those substances. Now, if you go even in rusting, don't forget the effects of rusting and how can we mitigate the effects of rusting. Allow me to pause at that and we go to an item under this topic. We go through it and then we see how best we can get done with item number 2. Don't get tired until the end. Today I have a full package for you for this paper 1. Today we are in details, not only details, identifying those mistakes. How do we approach this item number 2? There's something new which I just want to let us know, just something small. When you're looking at this item number 2, number 1, read the scenario and then identify one category of, it can be element depending from which topic it is coming from. It can be an element, it can be a compound, it can be any substance, it can be a material. Are we there? Categorize it. Now, give it the reason of the category. It can be the definition or the fact about that. Why are you calling it basic oxide? Give us the definition of what a basic oxide is, or the fact that you know. Give one example. Now, but this example is always given in the what? It should be in the scenario. That's why we normally say it should be related to the problem in the scenario. Why do we say the problem in the scenario? We believe whenever we are responding to these items, we are solving problems. So that is number one. Then number two, outline at least. Now, this is where I want us to be careful. Most of learners have been getting few scores. Why? When they reach here on the properties, they just want to give only one. When you give one, you get your one score, instead of getting at least maybe 3 scores. So we are saying that you give 4 properties and 1 use. We shall see how we can do this in our next example. So give 4 properties and 1 use of what? Of the substance you have identified in A above. Then give 1 use of the substance. Now they can ask such, give 1 use, or it can be a calculation. It can be a calculation. So if it is a calculation, you'll be able to calculate. Maybe it is under more concept and you're calculating, and it will give you 2 scores. Then state 1 impact of the element or compound, depending, of course. All these are put there depending on which topic we have set. So element, compound, substance, or material. Identify and write 1 mitigation. So you give impact, so we give the danger, you give explain it, and then you give the mitigation. Let's look at our example. I want us to go through this example very fast as I will highlight the key areas. So in this example, we're saying that a manufacturing company of steel kitchenware products uses steel scrap bought from local people. Recently, the supply of good quality steel scrap, is this spelling right? You will make it better. Steel scrap, okay. The supply of good quality steel scrap raw materials reduced, yet the demand for the kitchenware products is high. In a bid to get the required raw materials, the procurement officer of the company got a new supplier of better quality steel. For steel to produce good kitchenware, an expert advised that the percentage of iron in steel, should not be below 98%. So the percentage of iron in steel should not be below 98%. So this is something that we need to note, because maybe it is going to help us in one way or the other. So that is the support material. This is another item that came in one of the mock body. So I believe some of you could have come across such an item, and today we are going to see how best could we maximize all the scores to this item. So here they're saying that when 0.114 grams sample of steel was treated with dilute sulfuric acid, 44.8 cubic centimeters of hydrogen gas measured at STP was obtained. Now, what is this mass they have given us? This mass they have given us is for the samples of steel. Now, don't forget that steel, anyway, we're going to see that, is a sample for steel. Let's continue first. Steel contains iron. They have already told us that it contains iron, which reacts with the acid according to the equation. So when steel reacts with the acid, it produces, this is not steel, but when iron reacts with sulfuric acid, it produces iron sulfate and hydrogen gas. Task. As a chemistry learner, explain the category of the substance from which the kitchenware is made. Make the company understand why the substance in A above is preferred to pure iron in making kitchenware, and give one use. Help the company know whether the steel will make good kitchenware, and then give one danger of the substance and how it can be mitigated. Now, before we go any further, here they're saying the category of the substance. They want the category of the substance from which. So when you look at the category of substance from which the kitchenware is made, we have been reading and they're saying that the kitchenware is made from steel scrap, which means the material where kitchenware is made is steel. How do we categorize steel? Yeah, I saw most of learners are putting metal. Yes, steel is in the form of a metal, but steel has its own category. That's why we looked at the other one. So steel can be categorized as an alloy, because we call steel comprises of iron and carbon. It has these two, iron and carbon. So we say steel is an alloy. And we, of course, we don't end there. We say that in this case, we give the category, we give the reason, and we include the example. But this example should be in the scenario. So our example here is steel. Which category is alloy? We give the reason, because an alloy is a substance which consists of a metal. When it consists of a metal combined with other elements to improve on its properties. Then on part B, I just want to highlight, then we shall look at my response, which I have. Make the company understand why the substance above is preferred. So, to pure iron. So the substance above is steel. Are you seeing that? Why is it preferred to pure iron? So we are looking at the difference which is between the steel and the iron. The steel and the iron. So when you look at the steel and iron, the steel is an alloy, then iron is just a metal. So we need to look at what is the difference between this steel and the iron. So which means they want us to talk about the properties of alloy. Then finally help the company know whether the steel will make good kitchenware. How will you know? We need to do a calculation, because here they said that an expert advised that the percentage of iron in steel should not be below 98 for it to be good. It should not be below 98, which means you need to calculate the percentage of iron in steel. We see whether it is below or above 98. What are we going to use? There's information provided to us here. Then we'll be able to conclude. Then give one danger of substance, then we give the danger of steel and how we can mitigate. Okay, so when you look at part A, they want us to categorize. So we just, as we said, we have to keep on point. So here we are just saying that the kitchenware is an alloy. That is our category, because it's made up of mixture of metal with other elements to improve properties. So that is the reason. And then the example is steel, which is in the what? In the scenario. So when you give the good category and you give the reason, you get all your 4 scores. Are you seeing that? So that is, now some people were categorizing it as a metal. No. Steel is not categorized as a metal. Instead, it is categorized as an alloy. Then, part B, why is steel preferred to pure iron? So, which means in this case, they want us to give properties of the steel, which is an alloy. So, let's see. Here we give properties, and we say that we give 4 properties. We give 4 properties and 1 use. Now, if you are giving 4 properties and 1 use, 4 properties and 1 use, for you to get all the scores. So which means here we can say steel is harder, this is the property, stronger, and more resistant to corrosion compared to pure iron. It also withstands high temperatures without losing shape. How many properties are those? 1, 2, 3, 4. Why are we using the words harder, stronger? It is because we are comparing it with pure iron. Even iron is hard, but steel is harder. Even iron is strong, but steel is stronger. Steel is more resistant to corrosion compared to also iron. Then use, we are saying steel is used in making kitchen utensils such as cooking, pots, knives, and cutlery. Why? Because of these properties. So this is 1 use, and you get all your 3 scores. Hope that one is clear. Then part C. Part C, what was it asking? Part C is asking to advise these people whether it will work, whether it will do the work it is supposed to do. And we said that for us to get this, we need to be looking at, we need to calculate. We need to go back and we calculate. Part C, they said help the company to know whether the steel will make good kitchenware, which means we need to calculate whether the iron present in steel will give us the actual percentage. So we're going to use this. We are seeing here, you can note these ones down so that we don't come back. Number 1, we are given the mass of steel is 0.114 grams. Then the hydrogen produced was 44.8 cubic centimeters. I believe those are the things that we need. Now we can go to our next slide where we have reached. So part C, they want us to advise the company whether it will work. Now there's one thing that we have, the equation that iron reacts with sulfuric acid to produce. I believe we learned how to interpret equations. So which means here we can say that 1 mole of iron reacted with 1 mole of sulfuric acid to produce 1 mole of iron sulfate and 1 mole of hydrogen. Now we need first to check whether it is balanced. Is the equation balanced? We have 1 iron atom, 1 iron atom, 2 hydrogen atoms, 2 hydrogen atoms this side. Then sulfur only 1, even here only 1. Oxygen 4 atoms, even here oxygen 4 atoms. So which means our equation is balanced. Now there are some things that we have. They are telling us that when 0.114 grams of steel reacted with sulfuric acid, they are telling us that 44.8 cubic centimeters of hydrogen was produced. Are we saying that? So they have given us now this mass is for steel. Now steel consists of 2 things. It consists of carbon and iron. But carbon does not react with is not reacting with the sulfuric acid. So which means iron present in steel is the one which is taking part in the reaction. Now the full mass for steel that reacted is 0.114 grams, and it produced 4.448 cubic centimeters, and they told us it was a STP. Are you seeing that? So what we have is iron present in steel, but we don't know how much iron reacted, because this is the mass of the whole steel, but steel consists of iron. So you need to find out which mass of steel reacted to produce this volume of hydrogen. Then we can determine the percentage of steel. But there's one thing we know, that 1 mole of a gas at STP, since our volume is in cubic centimeters, it occupies 22400 cubic centimeters at STP. This one, they normally give it once, on the first page or on the question. Now, if we have all this and we know how to interpret, in simple terms, if I to read this equation, we say 1 mole of iron reacts with 1 mole of sulfuric acid to produce 1 mole iron sulfate and hydrogen. But our emphasis is on hydrogen and the iron. Iron, it weighs 56 grams. That is the molar mass of iron. And that is equivalent to 1 mole, which is the same as the molar mass. I'm summarizing these ones. I believe we all know that. So after that, then we can begin on calculation. So which means we can come here. And say, where is it now? So let's bring it here, and then we say that from interpretation, that 1 mole of iron reacts to produce 1 mole of hydrogen. Now, but we know that 1 mole of iron, it weighs its mass. So its mass is 56. So we say 56 grams of iron reacts to produce 1 mole of a gas. We already seen that it weighs what? 22400 cubic centimeters of hydrogen. Now, since we are given the volume of hydrogen, and we are looking for this, it's better what we are looking for to go on the other side, on the right hand. So which means we can start with this, that 22400 cubic centimeters of hydrogen was produced by 56 grams of iron. Now, if 224 was produced by 56 grams, what about 1 cubic centimeters of hydrogen? It was produced by, which means this will be 56 over 22400 grams of iron. If 1 cubic centimeter of hydrogen was produced by this mass, what about the one they gave us in the question? That is 44.8 cubic centimeters of hydrogen. It was produced by, so you get 56 over 22400 times 44.8 grams. What do we get? So we can get our calculator and we calculate together. We have 56 times 44.8 divided by 22400. So I'm getting 0. Okay, it is 0.112 grams of iron. So that is the mass of iron that reacted. Are you seeing that? But you recall that it was 0.114 grams of steel. And steel consists of iron and carbon. So you need to get the percentage of iron in steel. So which means it will be the mass of iron, which is 0.112 over the total mass we had is 0.114 times 100. What do we get? If we do very well the calculation, we should be able to get the answer. 0.112 times 100 divided by 0.114. I'm getting 98.25%. And in the question they say that if the steel consists of iron which is 98%, which is not below 98%, then that is a good one. So are you saying that this is a good one? Percentage of iron, this is of iron in steel. So we can recommend to these people that the steel will work since the percentage is above 98%. And you get all your scores. That is how they wanted us to calculate for that item. Now let's look at the last part, which is part D, the side effect of the product and its mitigation. So side effect, we can say steel rusts when exposed. Rust, that is the danger. It rusts when exposed to air and moisture, that's weakening the material. This can be mitigated by applying protective coatings. That is the mitigation, like galvanization, stainless steel with chromium, or regular drying and oiling after washing. But you need to put only one. So there we get all our 3 scores. Here we got our 2 scores. And finally we get out of 15. I believe that was a very nice item which we have gone through together. Go ahead and try more other numbers. I will have a session to take you through also a number of mock bodies, just showing you what was set in item 1, item 2 in one session. A number of them. I will bring for you a number of mock bodies. You see, what did they in this body set in item 1, item 2. But doesn't mean that is what is coming in UNEB, and you focus on only those ones. The reason why we do all this is for us to be equipped on different ways items can be set and how to test ourselves. Are we now ready to attempt an item that is set? Okay, section B. Now, section B part 1, I believe by now we all know that is about industrial processes. And we have different processes like manufacture of chlorine, sodium hydroxide, cement and lime, nitrate fertilizers, ethanol, biogas, oxygen, nitrogen. All these are done by the fractional distillation. In senior 1 work, go back and check. Nitrogen and oxygen. The difference is the boiling point at which they come out. Then detergent, look at soap and soappress, both industrial and maybe at home at a small scale. So please don't, there are some people, when they are manufacturing the soap, they want to say measure 1 cubic centimeter. At industrial level, you're measuring 1 cubic centimeter. So surely don't bring the laboratory preparation. Instead, according to the question, that is why they want the large scale. So large scale, it is industrial, and therefore it needs industrial manufacture. Then we have sulfuric acid, extraction of metals like iron, aluminium, copper. Yeah, last year in the UNEB they brought copper, and they also brought cement. That was last year's UNEB. But doesn't mean that now you start saying that because it was set last year, it cannot come back. Why not? Read everything and leave out nothing. Read everything and leave out what? Nothing. Please, read all the manufacturing processes. Then obtaining useful products from crude oil. There's a session I did also about this. Water treatment process, I looked at this in senior 1, and then we have nitric acid. So we can see that we have a number of them, and I think it's possible to see that we find that we have a given process that we have not mentioned. Then let me put etc and include it there, and also try it out. But what do we do under industrial process? Just something small to go through it very fast. So during industrial process, these are some tips I want to give to us. I've put examiner's tips, but also, of course, there are tips to us, the students also. Are we there? Number 1, mention the raw materials. Because when you read the scenario, you are supposed to be in position to identify the product they are producing, the product which is being manufactured, the product which is being produced. Now, after identifying this product, it's good for us to identify the raw materials. The raw materials, identify them. After identifying the raw materials, then the process of production of the what? Of this product. And we're saying that during the process of production, write the chemical equation clearly. And we say that you can write chemical equation, or you can write even the word equation, or the symbolic equations of those chemical equations. Then every danger must be explained. And we are looking at the side effects of the production process. Now, when you identify a danger, you are saying that explain it and don't forget to mitigate. Of what? Of the production process. Then social benefits with effect and impact of the production process. So don't just say it is used for it is used for breathing. How? And what is its impact? So we need to look at all those. Let's look at one example, and then we can wind up with part 1. So in the item, this is our third item. We have looked at item 1, item 2. Now this is our third item, and for it is about industrial process. Let's read. We identify the product we need to manufacture. So they're saying that aluminium is widely used in construction industry in Uganda. This has resulted into need for the material to meet the demands. It has resulted into need for the material to meet the demands. In one of the areas in Uganda, it has been found that there are many aluminium deposits. The government has cleared a local investor to set up a factory to produce the material so that he can tap into the opportunity. The community is puzzled about the process of extracting the mineral together with its effect on the environment and benefit other than employment. Through school head teachers, the investor has organized the radio and television talks to sensitize the community, and you have been chosen to present your school. Make a write-up of the presentation you will make. When I was reading, I found out that one of the things that we want us to produce, the product, is aluminium metal. Now, in this session, I will take you through aluminium metal. Now, I believe in the previous sessions I have taken you through, you have seen how copper is manufactured. As you are looking at UNEB paper, you have seen how cement is manufactured, and very many others, but also under metals, you have seen even iron, how it is manufactured. Now it is a turn for aluminium. So let's look at the solution. The solution. So in the manufacture of aluminium, we said we look at the raw material first. The raw material for aluminium is its ore, number 1, which is bauxite. This is the principal ore of aluminium. Then some impurities like silicon dioxide and iron 3 oxide. I'm going to take you through very fast. I believe you already know this, but for those who don't have this process, you can put it down. You can see it has been very well summarized. So we have different stages. Number 1 is during roasting. Number 2, during crushing. Number 3, during concentration. Then during electrolysis. So it undergoes 3 stages. During roasting, we are saying that the ore is heated. It is heated. This is a chemical process at high temperatures in blast furnace. This is a vessel, you get a score, to convert any iron 2 oxide to iron 3 oxide and drive off water vapor. Then, during crushing, the ore is crushed into fine powder. This is the physical process. When it is being crushed into fine powder, there's no new chemical change, there's no new substance formed. Instead, you are changing from a solid to a bigger solid, maybe, to powder form, reducing surface area. Now, increasing surface area. Now, during concentration, the fine powdered ore is heated. This is a chemical process. In a sealed tank, this is our vessel, with concentrated sodium hydroxide solution to form a mixture of sodium aluminate, sodium silicate, followed by filtration. Filtration, this is a physical process to remove the undissolved iron 3 hydroxide as impurity. I'm doing all this to show you where the marking points are. Carbon dioxide gas is bubbled at a high pressure through the filtrate or addition of pure aluminium hydroxide to the filtrate to solidify or precipitate out sodium aluminate. Okay, so the mixture is then filtered off to obtain solid aluminium hydroxide. This is the physical process, which is washed, dried, and heated strongly. This is heated chemical process to form aluminium oxide. So that is our equation. Now, during electrolysis, which is our last stage, molten aluminium oxide is reduced to aluminium. Okay, this is conversion to the desired product in electrolytic cell at this temperature. In an electrolyte of molten cryolite using graphite electrons. So at the cathode, aluminium ions migrate towards the cathode and undergoes reaction by gain of electrons, depositing aluminium metal. So the conversion is there. So we can see that we have managed to get our aluminium, and then this one we can add that it can be undertaken purification process, and in that case you are able to get all your scores. Here you get your 4, so 4 plus 2. Now you say that raw materials can be mentioned in the process of production, or you can put them first and list all of them. So we want all the raw materials, so it all gives you 6 scores. Then later we can look at these, where the side effect, and we say the side effect of the production process, giving the danger, explain that danger, and mitigate. Social benefits, you give a benefit, its impact, and its effect. This one I want to give it to you to put it down, because I've already shared with you the side effects of manufacture of cement, manufacture of copper, manufacture of sodium hydroxide, manufacture of chlorine. All those ones are there. And do you think they're going to change on how we are going to put this? So please put those side effects and social benefits. What I wanted is to bring to your attention on the process of production. Please, for those who have not yet subscribed up to now, hit on the subscription button. That is the only way that you can make a follow-up of whatever I share. Otherwise, if you don't click on the notification and subscription button, you'll see this video today and you may not see it again. Why? because you didn't subscribe, it will not be among your liked and etc. So like the video, share to your friends so they can always also benefit from whatever we share. Share, like, subscribe, and please don't forget to leave a comment if it has been good session for you. Why not leave a comment, and also let me know which other area we can cover next, so that we can keep on pushing together. One mission, one goal. We all want to hit a target of performing better, becoming good citizens of Uganda, ready to change our nation. Ready to change our nation. People can identify problems and devise means to mitigate those problems. Problem solvers, critical thinkers. As we dive into our last part of our paper, that is section B, part 2. We said section B, part 2 is about natural resources. And we said we have different examples of natural resources. Number 1, we have air, we have water, we have rocks and minerals, fossil fuels, we have vegetation. On vegetation, I put for you a tree, meaning even trees are part of this vegetation. Fossil fuels, we have a number of them. We have coal, we have crude oil, we have natural gas. Those are fossil fuels. Now, when we look at this part of natural resources, I normally tell learners that this is an area I expect everyone to get a 15 out of 15. Let's see how you get all that 15. The first, I expect you to have at least 3 paragraphs. Don't be wordy. Don't write a lot of words. I need 3 paragraphs. Paragraph 1, include the category, reason, and example of what? Of the natural resource. In simple terms, read the scenario, and from the scenario, identify the natural resource that is being affected. Identify the human activity which is affecting natural resource or the environment, and then tell us the importance of conserving that natural resource. Those are 3 paragraphs that you want. Now, every natural resource, make sure that you know its composition. And we say that this composition, we need at least 3 components. The components, we need at least 3 of them. So look for the 3 components of air. I believe you know them. For water, look for them. Rocks, look for them. Fossil fuels, look for them. Vegetation, do the same. Are we there? Now, that is our first paragraph. The second paragraph, look at that human activity which is in the scenario. Some learners have started. The scenario doesn't have cutting down trees, but because it's the one they know, they just talk about that. It's not about what you know, but it's about what is in the scenario, what is affecting in the scenario. So talk about its impact and mitigation. Here we say that we expect you to talk about the danger of that human activity, its effect, explain that danger, and then you mitigate. You'll be able to get. So in this case, when you do all that, you get all the 6 scores. Even here, here you get the 4 scores. And finally here, you get all your, these are 4 scores, these are 6 scores, and then you can get all the 3 scores. Now, benefit or importance of the resource. So that is our last paragraph. But as you give this, you give the benefit. After giving the benefit, tell us its impact and its effect. So we need to look at all the 3. That's why you'll be able to get all the 3 scores. If you don't, then you lose out some scores. Can we dive to our example? That is item 4. In this session, we have covered 4 items. 1 item for number 1, second for number 2. Then for section B part 1, we did 1, and this is one item we're going to do for section B part 2. I believe after here, you'll be able to go and do all the numbers. Do all the numbers that you have in different papers. If you get any issue, reach out to me in the text, in the message, or you can comment. Let's go through this item. They're saying that oil is a fossil fuel widely used around the world, especially for running machines. This natural resource is formed over millions of years from remains of ancient plants and animals and extracted from underground through drilling. There are many vehicles that require oil servicing in Uganda. This has caused the frequent spillage of engine oil around car garages due to vehicle servicing activities. However, many garages owners lack knowledge about the category, composition, environmental impact of oil spills, as well as importance of natural resource. The teacher of chemistry is taking you for community work to sensitize the garage owners and workers. Task: write the chemistry information you will deliver to garage owners and workers. So which natural resource are we talking about? Here we can see that we are talking about a natural resource, which is what? Oil. Yeah? Now, do we know the category of this oil? Can we give the reason? The example is already given. Are you seeing that? Then, can we give the composition of this? Then after that, which human activity is affecting? The human activity, we can read in the scenario. It is servicing, oil servicing activities. Servicing activities. Oil servicing activities. So we need to talk about the danger, the effect, and the mitigation. Then after, we look at the importance of the natural resource. Okay, let's dive into the response here. I'll just take you through as I score. I know by now you know what to do here. So oil, which is the natural resource we are talking about, is a non-renewable, that is a category, fossil fuel, because it takes millions of years to form. That is the reason. So here you get your 4. Its composition is mainly hydrocarbons such as alkanes. Alkanes, we have cycloalkanes, we have aromatics with small amounts of sulfur, nitrogen, and nitrogen compounds. So here we said we need only 3 components. We need 3 components, and therefore when you give at least 3, you'll be able to get 2 scores. Then here we have in the second paragraph, the major activity affecting oil in garages is engine servicing. So the human activity here is engine servicing, where used oil is frequently spilled onto the ground. Now, what is its effect? So oil spillage pollutes soil, that is a danger, making it infertile. And when carried by rainwater into stream and lakes, it spreads over the surface and blocks oxygen supply of aquatic life, causing suffocation and death. That is the effect. To mitigate this, oil should be collected in proper containers for recycling. That is the mitigation. Then finally, the importance. Oil provides fuel for transport, that is a benefit, which enables the movement of goods and people across the country. That is the effect. You can see that is our effect. Then this improves trade, creates jobs, and raises government revenue that is used to build infrastructures such as schools, hospitals, and roads. So that is our impact. So you can see that you can be able to get all your scores. And at that point, you have maximized all the scores. So final tips as we wind up, we're saying that number one, when you're attempting any item in chemistry, number one, read the scenario carefully. We have added the word carefully because it's possible for you to read the scenario and run very fast to respond. But you're saying read carefully and underline. I believe you have been seeing how I've been doing. You underline the key ones. Then write the chemistry. If it involves maybe industrial processes, like industrial process. If it involves equation, where possible, include it. We said you can use word equation or you can use symbolic equation. Then we're saying that every danger must be mitigated, should have a mitigation. And I believe on every item, there is a danger being talked about. Every item, from section A to section B. They're talking about side effects of this one. So there is a danger somewhere. We're saying that every danger must be mitigated. Then every evaluation must show similarity and difference. I believe that one is majorly on item 1. Then don't waste time on greetings. I've seen some learners starting a message and say, hello, I'm this and coming from this. So putting a lot of ones which are not necessary. So all that introduction is not important. What you need is to make write-ups. Okay. Then if you write equations, we need to balance the equations for us to get all the full marks. Then show social and environmental impacts. So these are the key points. Note them down and follow them. I believe we shall be able to attain our A's. So we are saying that chemistry is everywhere, and therefore just enjoy the beauty of chemistry. We come to the end of our presentation. This presentation is being made by Nyirimbibi Isaac. That is the telephone number down there. You can reach me on that. And for other educational resources like practical books, we have the book called Remedy to Chemistry for paper 1. It is a masterpiece that you need to have. You're whether a teacher, a learner, you can please order today, call on that number or inbox on that number, and you'll be able to have those books ready for use. Otherwise, I want to wish you the best. Let's meet in our next session as we go through paper 2, as we look at the final touches for paper 2 as we approach to UNEB. Let's meet in the next session. Have a blessed time. God bless.